Hey guys, welcome back to my channel. In today's video, we are going to see how to remove duplicates from a sorted array. So an array will be given, we have to remove the duplicates, right? So let's read the question. Given an integer array num sorted in non-decreasing order, remove the duplicates in place such that each unique elements appear only once. Okay, so the relative order of the elements should be kept the same. Then return the number of unique elements in nums. Okay, so we have to return the number of unique elements. So we have to count the unique elements, I guess. So consider the number of unique elements of nums to be k. To get accepted, you need to do the following steps. Okay, so let's say there are k unique elements in nums. So let's see what we need to do before submitting it. Change the array num such that the first k elements of nums containing the unique element in the order they were present in nums initially. The remaining elements of nums are not important as well as the size of nums. Okay, so what basically this says is there are k unique elements in nums, right? So the first k numbers, or let's say the first k elements of the nums should be those unique elements, and then rest of the numbers, like rest after those k unique elements, whatever comes next, we don't have to care. We can return whatever we want, right? So let's look at the examples. So 1 1 2, here the unique elements are 1 and 2, right? So we are returning those 1 and 2 at first, and then we can return whatever we want. So here it's written like dash, but we can fill whatever we want. We can, let's say, write 1 2 2, 1 2 3, 1 2 5, 1 2 6, whatever you want you can write. So let's look at the second example. 0 0 1 1 1, okay, 2 2 3 3 4. So here also 0 1 2 3 4. So we are storing 0 1 2 3 4 in the first k indices. K is basically what? The number of unique elements, right? So basically there are 5 unique elements. So the first 5 blocks are filled with those unique elements, and rest of the blocks we can fill whatever we want. So that's the reason it is mentioned. It does not matter what you leave beyond the returned k, hence they are underscores. So the question is simple. So let's understand the question once again. So there are like these many elements are there. Let's find how many unique elements are there, right? So the unique elements are 0 1 2 3 and 4. So the resultant array, it should be the same array. We are not returning any array, we are returning the number of unique elements. So here k will be 5. Why? Because there are 5 unique elements here. So what we are going to do, we are going to change this input array and we are placing these elements at first. So we are like removing this 0 and placing this 0. Okay, it's the same thing. We are placing 1 in this place. So 1 will come here, then 2 will come here, 3 will come here, 4 will come here. Then rest of the elements we can put, or we can put whatever we want, right? So the question is simple. We just have to place these elements and we just have to return the number of unique elements, right? So whenever I'm talking about unique elements, right, so which data structure stores unique elements? Which data structure stores unique elements? Can I say set stores it? Right. So set stores only unique elements. So what I'm going to do, I'm going to push all these elements inside this set, and then set, let's say, st.size will give that k. What is k? K is basically the number of unique elements, right? And what I'm going to do, I'm going to iterate in the set, and then I'm going to place those elements here. So let's see how this works, right? So I'm maintaining a set data structure, and I'm just iterating once, right? So 0 comes, I'm putting 0 into the set. So set contains 0. I'm going to the next index. Set doesn't store duplicates, so 0 won't be inserted. So 0 again comes, okay, 0 is already present. 1 comes, okay, 1 is not in set. So 1 will be inserted in the set. Okay, so 1 again comes, 1 won't be inserted, again comes, 2 comes, 2 comes, right? So 2 will be inserted, 2 again came, 2 is already there, so 2 won't be inserted again. Here 3 comes, so 3 is getting inserted, so 3 will get inserted, then here comes 4, and here 4 will get inserted. So these all are the unique elements. And how many unique elements are there? Let's say set, we are naming it st. So st dot size will be having those unique elements, right? And now we have to place this in this array. So let's say I'm going to maintain a pointer, let's say ptr or I or j, whatever you want to take. I'm taking ptr, right? Ptr equals 0 at first, and what I'm going to do, I'm going to iterate through set, right? And I'm going to place the value in ptr index. So it will be stored in ptr. Then I'm going to increment this ptr for the next unique element, right? So ultimately what happens in this code is ptr 0 at first, set will go to this element. So when ptr is 0, 0 will be placed here, okay. Then ptr got incremented, so let's say ptr is here right now. Then set points to this element, and in this ptr, the it will be in the ptr, right? So it right now is here. So 1 will get placed here, then ptr will increase, then it will be pointing here, and the ptr will be here. So 2 will be returned here, then it will be 3, and ptr will point to the next index. So 3 will be returned here, right? So likewise 4 also will be returned here. So like this we can solve it. So let's look at the code. So the code looks something like this. We are maintaining a set, and then we are inserting all the elements in the set, right? And then we are keeping a pointer int. Then we are iterating through this set using for each loop. And then nums of index, we are going to store that element. Then we are going to increment. So these two lines are written in a single line here, and we have to return what? K. What is K? The number of unique elements. So basically st.size will give the number of unique elements. So the time complexity of this code will be, let's analyze. Okay, so this loop will be taking n log n time. Why? Because to insert or to maintain a set, you are taking around log n time complexity, and this loop runs for n times. So overall time complexity will be n log n for this loop. Here in this loop, at worst, it's going to run n times. So the time complexity is basically n log n plus n. So basically O of n log n plus O of n. So space complexity will be, we are taking a set as an extra space, and at max it can store n elements. So space complexity will be O of n. So we have seen how to solve it using set data structure, right? So it's taking a space of O of n. But what if I am saying, bro, don't use this, don't use any space, try solving it without using any space, right? So without using any space, that means we have to modify something in this. So can I use some pointers to do that? Right, we are going to use two pointers approach. We are going to keep 2 pointers and then solve this question. So what I'm going to do, I'm going to keep 2 pointers, first here, the second one here. So P1 will point to the 0th index, P2 will point to the first index at first. So what P1 will make sure is that all the elements to the left of P1 should be unique. It should be unique, including the current element, right? And what P2 will make sure is that to get all those unique elements and give it to P1. So what I'm going to do, let's look into the algorithm. So P2 will be iterating from this index till the last index, and while iterating I'm going to check, bro, if P1 and P2 is same or not, right? In this 0 and 0 they are same. So what I'm saying, bro, don't do anything, go ahead. So P2 will be pointing here, still they are same. I'm saying, bro, don't do anything, go ahead. Now P2 is here, right? P1 is 0, P2 is 1, they are not same. So what I'm saying, bro, I got a new unique element. So what I'm going to do, I have to store this 1 here. So I will just do something like P1 plus plus, like move this P1 one step forward, then store this P2 in this index. So what I'm going to do, I'm going to do this operation, then AR of P1 will be storing AR of P2. Then again I'm going to move this pointer, right? So P2 will be here. Okay, I have to change this pointer. Now P1 is actually here and the element is 1. So P2 is here, P1 and P2 both are same. Okay, move forward. Still both are same, move forward. 2 came, 2 is not same. So bro, move this P1 one step forward and store this 2 here. So 2 will be stored here, P1. And now P2 will be again incremented and P2 will be checking with this 2, 2, both are same. P2 will go here. Okay, they are not same. I got a new unique value. So I will increment this P1. So P1 will come here and I am going to store this 3 here. So it will be 3. And now I am going to change P2. I am going to change P2 to the next index, right? P2 will come here. Now 4 is there and here 3 is there. They are not same. So bro, please increment this P1 and put this 4 here. So 4 will come here. And now P2 will be incremented and P2 will go out of the index. Now stop iterating. And we have got the array that we just needed, right? But bro, we have to return k. What is k? Basically the number of unique elements. So can I say P1 is the last point where the unique element is stored, right? So from 0 to P1, those k unique elements are stored. So how many elements are there? Can I say P1 plus 1? P1 is basically the index. So that index, in this case it's 4 plus 1. I'm having 5 unique elements. So that's how we are going to solve this. Okay, so here is the code. This I is basically the P1 that we took, and this J is basically the P2 that we took. So J is iterating and we are checking whether the first and the second value is same or not. If they are not, that means if they are different, we are saying, bro, move one step forward and then store the jth value in ith value and move this j till j is lesser than n, and we are returning I plus 1, right? So basically I will be pointing to the last index where that last unique element was stored. So I plus 1 will give the size of unique elements, or it will give the total number of unique elements. So that's how we just did it using time complexity of n, because this loop will go for n times and we are not using any extra space. So time complexity will be O of n and space complexity will be O of 1. So I hope you got to know how to solve it using set, and then how to solve it using 2 pointers also. So that's it for the video. If you like the video, hit the like button, subscribe to our channel. Until next time, see ya.